Okay, let's talk about lists. So basically a list is an ordered collection of objects. So a data frame is actually a list, and the objects that they're talking about are the columns. So if you're talking about a data frame, so you'd have the columns. Those are the objects that they say an ordered collection of objects is a list. So a list allows you to gather a variety of objects under one name. For example, a list may contain a combination of vectors. So a data frame is a combination of vectors, but a list is more flexible than that. So you could have vectors, but you could also have matrices and even data frames. So a list could be a collection of data frames actually, and even other lists. So it's more flexible than a data frame. A data frame can only contain vectors, right? A combination of vectors. But a list can contain a combination of lots of different things. And you create a list by using the list function, for example, here. So it's very similar to creating a data frame and collecting the objects inside. But in a list, the objects are more flexible here, where the objects are any of the structures seen so far. Optionally, you can name a list, name the objects in a list, so you can do it this way. So instead of just writing object, you can say name 1, object 1, name 2, object 2, and so on. So let's look at an example. So we'll have a string here, and call it G. And then we'll have a vector here, and call it H. And we'll have a matrix here, right? That's a matrix, and call it J. And we'll have another vector here of strings, and call it K. And now we're going to create a list, and there's an so we're creating a named object here. The name is title, and the object is this single string. And then we're entering another object as a named object, and the name this time is ages, and it's a vector with 4 elements. And then J is the matrix, and that's also part of the list, and K is this vector of strings. So you can see that the list is very flexible, can hold all kinds of things. Now we're assigning it to this variable mylist, and let's see what happens when we print out mylist. So this is the way it prints out. So you get a printout like this, and then it lists what's in there. You get a printout like this, and it lists what's in there. The next thing was the matrix, but it wasn't named, right? It was just J, it wasn't named. So what it does is it prints out the matrix here, and this is kind of the indicator that it's the third element. Okay, now we haven't really seen that before, this kind of indicator, but it means it's the third element in a list. And then this will mean that it's the 4th element in the list, and that was this vector of strings. Now if you want, here's another way to access the different elements of the list, and this would be accessing the second element in the list. By the second element in the list, again, we mean that this one here is the second element in this list, right? So we're accessing ages. In other words, we're accessing this vector. So let's see again. What does that look like? Here, the second element in the list is the ages vector. Or you can also access the ages element in the object in the list as like this. Instead of having 2, meaning the second one, since it was a named element, you can use the name here. I guess you have to have these there, though. Okay, so again, we create the list using the list function. We can either give names like this using the equal sign, or we can just do this and this. And the thing is that we can have all kinds of things in this list. And then to see what they look like, we can type out the whole name of the list, and we'll see the display like this. But again, this means what? This means the third object in the list, which was J, which was a matrix. And that's why it displays as a matrix. And this means the fourth object, which was this character vector, or string vector. So that's why it displays like this. And then you could access the second object in the list this way, or using the name since it was named. So he says, in this example you create a list with 4 components: a string, a numeric vector, a matrix, and a character vector. You can combine any number of objects and save them as a list. You can also specify elements of the list by indicating a component number or a name within double brackets. So here we have the 2 inside these double brackets, and here we have ages inside these double brackets. They say both refer to the same 4-element number vector, numeric vector. He says lists are important structures for 2 reasons. First, they allow you to organize and recall disparate information in a simple way. In other words, you don't have to worry about the fact that everything is the same type, like everything is numeric, like you have to in an array or in a matrix or in a vector. And even you don't have to worry about everything being the same size like you do in a data frame. You know, in a data frame, all the columns have to be of the same length, right? You have to have the same number of rows in each column. But for for a list, you don't have to do that. And also, the results of many R functions return lists. So when we see the summary, we used the summary function before. Remember, that gave us a kind of summarization of the different elements, the different variables, like it gave us the mean and the median and so on. That actually is stored as a list, and it's presented kind of as a list as well. Okay, it's up to the analyst to pull out the components that are needed. So they might be stored as a list, and then you just want one object from that summary report, perhaps, and so you access just one of the objects in the list, basically in the way that we've just seen by using the double brackets. Okay, he says you'll see numerous examples of functions that return lists in later chapters. Okay, let's stop here and then we'll look at this in Note for Programmers.